Hey, this is the second of the last lecture in Unit 2, and what we're doing in Unit 2 is we're looking at force and forces. And what we're going to do today is take a look at one formula for friction and how you can determine friction if it's not given in a question, but they ask for the friction to answer the problem. Now, there's two main types of friction. There's static friction and there's kinetic friction. So the reason they divide it up into the two types of frictions is if you've got a block and it's sitting there stationary is static, if it's sitting there stationary on concrete, it's harder to get it moving than it is to keep it moving. So static friction is always going to be greater than kinetic friction. So the friction level is going to go down once the object is moving. So usually when you look up friction on a table, they're going to ask you, is the object moving or not moving? Because that's going to determine the amount of friction you have. Now, once again, this is an introductory course, so if you wanted to go deeper in, we could have different types of forces of friction. So we could have air resistance. So as a ball is going through the air, technically it shouldn't be slowing down because it's got no force slowing it down, but it does have air resistance slowing it down, so the ball will slow down in the real world. We also have something called rolling friction. Just because something is rolling doesn't mean there's no friction there. There is friction, but we are going to focus on static friction and kinetic friction. The friction of being still, the friction of moving. Now, it's very important to take a look at the types of factors that affect friction. So the type of material is important. So if you've got concrete on concrete, that's different than ice on ice. The mass is very important. So in the formula we're going to learn, you need to know the mass of what you have. Picture a 1 kilogram brick on a surface versus a 1 ton brick on a surface. Which one would be easier to push? Now another one is surface area. So if the brick is more spread, whoa, wait a minute. Surface area plays no role in friction. You have to get that straight. Type of material and mass are important, but the surface area is not important, and that can be shown in the mathematical formulas. Now, if we are doing calculations for friction, the coefficient of friction is shown by the symbol mu. So this is the coefficient of friction. And so a low number like 0.1 would be like a puck on ice, very little friction. A higher number like 0.9 would show that there's greater friction. If you're ever confused, look it up. So if you know you've got two wooden blocks, look up the coefficient of friction of wooden blocks. It helps to know what kind of wood it is. The other thing you need to know to get the force of friction is the normal force. So for example, if we had a 10 kilogram brick, then to get the normal force, which would be equal and opposite to the force of gravity, so it would be 10 times 9.8, which is 98 newtons. In this case, our normal force would be 98 newtons. So once you calculate your normal force and your coefficient of friction, you can get your friction for any problem. Now, the other question they might ask you is, what is the coefficient of static friction, or what is the coefficient of kinetic friction? Notice that these two formulas for static friction and kinetic friction are the same. The only thing that changes is when you look it up in the book, the coefficient, you have to know whether the object's moving or not. But the other question they can ask you is, what is the coefficient of friction? All I've done is rearrange this formula here to put the static friction over the static forces over the normal forces. So in this case, they would have to give you the force of static friction in the problem, and you could calculate the normal force. And when you divide those, you get the coefficient of friction. I'm going to go off on a tangent. Oh yeah, there are no units for the coefficient of friction. Okay, because you have newtons and you have newtons for force, they cancel each other out. So there are no units there. Now, I'm going to go off on a tangent for a minute. No pun intended here. But if another way that you could find the coefficient of friction is to put something on a ramp and lift that ramp up until that object just starts to move. If you take the tan of that angle, that's your coefficient of friction. So say we had a board laying flat, we put a puck on the board, so we wanted to know what the coefficient of friction is for rubber on wood. We start lifting that ramp up. As soon as that puck just starts to move, we take that angle, take the tan of the angle. That would be the coefficient of static friction right there. I want to go through just a quick question. So if we said we have an applied force of 50 newtons, so that says F applied of 50 newtons on a 10 kilogram brick, we could find the force of gravity, mass times acceleration, 98 newtons. We could find the normal force, 98 newtons. Notice there's no acceleration in the y direction because these are not unbalanced forces, they're the same. But what we could find now is we could find the force of friction. The force of friction would be equal to mu times that normal force, which is 98. Let's say in this case, the mu value is 0.2. I just made that up. I could have looked up what these materials were, and I could have looked up this friction. And the normal force is going to be 98. So we're going to have about 19.9 here for our force of friction. What you should see here is in the x-axis we have unbalanced forces. We have greater force here than we have force here. So we are going to have some type of acceleration. So acceleration would be equal to force net, so that 50 minus the 19.9 over the mass of 10 kilograms. So that's going to be about 3 meters per second if you calculated that force net and divided it by that mass. Folks, that is the force of friction. There are 4 sections here, or 4 activities that are primarily going to be on the test. There's going to be one more video, and it's going to be on the force of gravity, and that's going to be coming up next.